Good evening, everyone. Today I'm going to talk about language modeling in natural language processing. Before going into language modeling, we will look at what is natural language processing. Natural language processing is a subfield of artificial intelligence and linguistics that focus on enabling computers to understand, interpret, and generate human language in in the way that is both meaningful and contextually relevant. NLP aims to bridge the gap between the human communication and understanding and allowing machines to interact with humans using natural language. The ultimate goal of NLP is to enable computers to process, analyze, and generate human like language just as humans do. Language modeling. What is language modeling? Language modeling is the use of various statistical and probabilistic techniques to determine the probability of a given sequence of words occurring in a sentence. Language modeling is a fundamental concept in the field of natural language processing. It involves building computational models that can predict the next word or character in a sequence of words or characters based on the context provided by the preceding words. These models are trained on large datasets of text, learning the statistical pattern and relationship between words. The primary goal of language modeling is to capture the underlying structure and patterns of human language and enabling machines to understand and generate the text that resembles human written language. Language models analyze bodies of text data to provide a basis for their word predictions. They, they are used in natural language processing applications, particularly in those applications that generate text as an output. Some of these applications include machine translation and question answering. Now let us see that how language modeling works. Language model determine word probability by analyzing text data. They interpret this data by feeding it through an algorithm that establishes rules for context in natural language. Then the model applies these rules in language tasks to accurately predict or produce new sentences. The model essentially learns the features and characteristics of basic language and uses those features to understand the new phrases. There are several different probabilistic approaches to modeling language, which vary depending on the purpose of the language model. From a technical perspective, the various types differ by the amount of text data they analyze and the math they use to analyze it. For example, a language model designed to generate sentences for an automated Twitter bot may use different math and analyze text data in a different way than a language model designed for determining the likelihood of a search query. Some of the common statistical language modeling types are n-gram modeling, unigram model, bidirectional model, exponential model, and continuous space model. First, we'll look at n-gram model. It is a statistical language model that is used to predict the likelihood of the next word in a sequence given the previous n minus 1 words. N-grams are relatively simple approach to language models. They create a probability distribution for a sequence of n. The n can be any number and defines the size of the gram or sequence of words being assigned a probability. For example, if n is equal to 5, a gram might look like, can you please call me? Like it may look like 5 words. The model then assigns probabilities using sequences of n size. Basically, n can be thought of as the amount of context the model is told to consider. Some types of n-grams are unigrams, bigrams, trigrams, and so on. Next, we'll look into unigram model. Unigram model is the simplest form of n-gram language model, where n is the set to 1. In other words, a unigram model predicts the likelihood of each individual word in a sequence based solely on its own frequency in training corpus. The unigram is the simplest type of language model. It does not look at any conditioning context in its calculation. It evaluates each word on or term independently. Unigram model commonly handle language processing tasks such as information retrieval. The unigram model is the foundation for more specific model variant called query likelihood model, which uses information retrieval to examine a pool of documents and match the most relevant one to the specific query. Next model we are going to look is bidirectional model. A bidirectional model in NLP refers to a type of model that takes into account both the left and right context of a given word or token when making predictions. The approach contrasts with the traditional language models, which only consider the preceding words. Unlike Ngram models, which analyze text in one direction, that is only in backward direction, bidirectional model analyze the text in both in forward and backward directions. These model can predict any word in a sentence or body of the text by using every other word in the text. Examining text bidirectionally increases result accuracy. This type is often utilized in machine learning and speech generation applications. For example, Google uses a bidirectional model to process search queries. Next, we are going to see exponential model. It is also known as maximum entropy model, and exponential model is also known as maximum entropy Markov model, and it is a probabilistic framework used in natural language processing for classification and sequence labeling tasks. It is based on the principle of selecting the model that makes the least assumptions. That is, least assumptions means which maximizes the entropy while still being consistent with the training data. This type is more complex than n-grams. Simply put, the the model evaluates text using an equation that combines a feature function and n-grams. Basically, this type specifies feature and parameters of the desired results, and unlike n-grams, leaves analysis parameters more ambiguous. It doesn't specify individual gram sizes. For example, the model is based on the principle of entropy, which states that the probability distribution with the most entropy is the best choice. In other words, the model with more choice and least room for assumptions is the more accurate. Exponential models are designed maximize cross entropy, which minimizes the amount of statistical assumptions that can be made. This enables users to better trust the results they get from the models, from these models. Next, we are going to see about continuous space model. Continuous space model in natural language processing refers to a type of model that represents word, phrases, or sentence as points in a continuous vector point space. These models encode semantic and syntactic relationships between the words based on the vector representations and enabling various NLP tasks like similarity measurement, sentimental analysis, and language generation. One of the most continuous space model is word to vector model. The, this type of model represents word as a nonlinear combination of weight in a neural network. The process of assigning a weight to a word is also known as word embedding. This type becomes especially useful as data sets get increasingly large because larger data sets often include more unique words. The presence of lot of unique or rarely used words can cause problem for linear model like an n-gram model. This is because the amount of possible word sequences increases when the amount of possible word sequences increases and the patterns that inform results become weaker. So by weighting words in a nonlinear and distributed way, this model can learn to approximate words and therefore not be misled by any unknown values. Its understanding of given word is not as tightly tethered to the immediate surrounding words as as it is in n-gram models. So for the models listed above are general statistical approaches from which more specific variant languages models are derived. For example, as mentioned in the n-gram description, the query likelihood model is a more specific or specialized model that uses the n-gram approach. Model types may be used in conjunction with one another. The models listed also vary significantly in the complexity. Broadly speaking, more complex the language model or better at NLP task because language itself is extremely complex and always evolving. Therefore, an exponential model or continuous space model might be better than a n-gram for NLP task because they are designed to account for ambiguity and variation in language. A good language model should be also be able to process long-term dependencies, handling words that may derive their meaning from other words that occur far away, disparate parts of the text. In language modeling, and language modeling should be able to understand when a word is referencing another word from a long distance as opposed to always relying on the proximal words with a certain fixed history. This requires more complex model. Now let us see about importance of the language modeling. Language modeling is crucial in modern NLP applications. It is the reason that machines can understand qualitative information. Each language model type, in one way or another way, turns a qualitative information into a quantitative information. This allows people to communicate with machines as they do with each other to a limited extent. It is used directly in a variety of industries, including technology, finance, healthcare, transportation, legal, military, and government. Additionally, it is likely most people reading this or hearing my conversation with a language model i- is interacted with the will have interacted with the language model in some way or at any point of the day, whether it may be a Google search or autocomplete text function or engaging with a voice assistant. The Now let us see some examples of language modeling. Text generation. Language models are essential for generating coherent and contextually relevant text. The power applications like chatbots, language translations, content creation, and creative writing. It is used in machine translation. Language models aid in machine translation by understanding the structure and semantics of the text in one language and generating equivalent text in another language. Language modeling is also used in speech recognition. Like language modeling is used in recognition system to enhance accuracy by incorporating language patterns and context to decipher the spoken words. Language modeling is used in sentimental analysis. Models trained on language patterns can analyze text sentiment, determining whether a piece of text expresses a positive, negative, or neutral sentiment. Text completion and prediction. Language model predict that next word or phrase in a sequence, making them valuable for text completion and suggestions in the Google search engines, smartphones, and word processors. It is also used in named entity recognition. Named entity recognition systems use language models to identify and classify entities like names of people, organizations, locations, and more in the text. Language modeling is used in text summarization, like language models help in summarizing long text by identifying key sentences or phrases that capture the essential information. Language modeling is used in question answering. In question answering systems, language models understand the question and generate answers based on the available information. Language modeling is also used in language understanding. Language modeling aids in understanding the context and nuances of human language, enabling better communication between the humans and the machines. Content recommendations. Language models are employed in recommendation systems to understand user preferences and generate personalized content recommendations. Search engines. Language models improve search engines by understanding user queries and retrieving relevant information from vast data sets. Language models are also used in conversational AI, like chatbots and virtual assistants, leverage language modeling to understand and respond to the user queries naturally and creating a more engaging human computer interaction. Now I'm going to discuss about my project. And our project title is Next Word Prediction. In today's fast paced digital communication landscape, the efficiency of text input plays a crucial role in user experience. Whether it is composing an email, crafting a message, or conducting an online searches, the speed and accuracy of text entry matters a lot. To enhance this experience, we present a project focused on next word prediction. This project leverages the power of natural language processing and machine learning to predict the next word a user intends to type or speak, making the text input faster and more intuitive. By analyzing extensive text data and user specific patterns, our goal is to create a predictive system that seamlessly integrates into various applications and platforms, ultimately improving user productivity and satisfaction. Coming to the abstract of our project, our system aims to predict the most likely next word a user intends to type or speak, thus accelerating text entry across various devices and applications. We detail the methodology, data sources, and model architecture employed in our project. Efficient and intuitive text input is crucial in today's digital world. This project explores the development and implementation of next word prediction system using natural language processing and machine learning technique by analyzing vast text corpora and user specific data. Our system aims to predict the most likely next word a user intends to type or speak, thus accelerating the text entry across various devices and applications. We detail the methodology, data source, and model architectures employed in our project. Additionally, we evaluate the system's performance in terms of prediction accuracy, latency, and user satisfaction. The results showcase the potential for improved text input methods that can benefit users in both productivity and accessibility. The objective of a project is to create a predictive text system that can suggest the most likely word or words that would come next in a given sentence or text fragment. This project typically involves natural language processing and machine learning techniques to build a predictive model. The expected outcome of a project or improved text input efficiency. Users will experience faster and more accurate text entry, reducing typing effort and increasing productivity. Enhanced user experience, reduced errors, adaptability, compactability, and data insights. Coming to enhance the improved text input efficiency. With this, users will experience faster and more accurate text entry, which reduces the typing effort and increases the productivity. The system should provide intuitive and contextually relevant suggestions, which will enhance the user experience and leading to improved user satisfaction. It will lead to reduced errors, fewer typos and spelling mistakes in the text input, resulting in higher quality written content. It increases adaptability. The model should adapt to user specific language pattern and preferences over time. Further enhancing prediction accuracy, compatibility, integration into various devices and applications for seamless and widespread use. Data insights, valuable insights into user language behavior and preferences for the potential refinements or future applications. Thank you.